Welcome to testing of materials, lecture number 5, other testing. So here we are going to see the other testing methods for testing the materials. Okay. So here material testing, measurement of the characteristics and behavior of such substances such as metals, ceramics or plastic etc. under various conditions can be tested in this testing. The materials testing breaks down into major categories: mechanical testing and non-destructive testing, testing for physical and chemical properties, testing for electrical properties, testing for resistance to corrosion, radiation and biological deterioration. And the next one we are going to see is the thermal analysis. So thermal analysis is a form of analytical technique most commonly used in the branch of material science, where changes in the properties of materials are examined with respect to temperature. It is a group of techniques in which changes of physical properties or chemical properties of the sample are monitored against time or temperature, while the temperature of the sample is programmed. The temperature program may involve heating or cooling at a fixed rate, holding the temperature constant, or any sequence of these. The sample is subject to a predefined heating or cooling programs. So the next one we are going to see is the thermal properties. Okay, so each thermal properties has some kind of measurements. Thermal conductivity is nothing but it is determining the temperature as a function of time along the length of a bar or across the surface. So our material will be in the form of a bar, or so that we can test the bar, or we can check the conductivity of the material's surface. Okay. Then the specific heat, it is given as a heat absorbed per unit mass per degree change in temperature. Thermal expansion due to heat is usually measured in linear fashion as the change in the unit length of a material caused by 1 degree change in temperature. Thermal stress, the stress experienced by body due to either thermal expansion or reflection. Okay. The thermoelastic effect: when a solid is subjected to a load, work is done on it and it changes in volume. This will appear in the form of rise of temperature of solid when it is stretched. And also we have thermal shock, then melting point or heat resistance, and emissivity of materials. Then we are going to see the thermal testing. So thermal testing involves the testing a product at the extreme of its intended use. So thermal environment for heating rate, temperature and airflow on gaseous atmosphere or vacuum, with measuring case temperature of individual components to determine the effect on product performance and long-term reliability. It measures based on dynamic relationship between temperature, mass volume and heat of reaction. Okay. The major methods of thermal testing are differential thermal analysis, dilatometer, differential scanning calorimetry, uh, dynamic mechanical analysis, thermogravimetric analysis, thermomechanical analysis, thermo-optical analysis. So other common methods of thermal methods includes dielectric thermal analysis, evolved gas analysis, laser flash analysis, derivatography. So these are the parameters of thermal testing. So the thermal gravimetric analysis checks the mass changes. Differential thermal analysis, it checks the temperature difference, and the differential scanning calorimetry, it checks the heat difference, and evolved gas analysis, it checks the gas composition. So the thermal mechanical analysis, reformation and dimension. Dilatometer, it checks volume, and dielectric thermal analysis, it checks the electrical properties, and thermo-optical analysis, it checks the optical properties. So differential scanning calorimeter is nothing but the energy is absorbed or released from the sample. So from that we can able to know that how the material it functions. by using this differential scanning calorimetry. Okay, so this is the principle, sample and reference are maintained at the same temperature or even during a thermal event in the sample. Okay, so if the sample is in hot condition, we have to maintain the same temperature. The energy required maintaining zero temperature difference between the sample and the reference is measured. Okay, so by calibrating the standard materials, we can able to know how the DSC calculates the absorption and so there are four types: the heat flux DSC, power compensated DSC, modulated DSC, hyper DSC, and pressure DSC. So here are the heat flux DSC and power compensated DSC are the two most important differential scanning calorimetry. So let's see first what is meant by power compensated DSC. So this is the pictorial representation of power compensated DSC. So here we have a heat sink, then we have sample and reference. So sample and reference should be kept at the same temperature. For measuring that, here we have a platinum resistance heaters for heating the furnaces. So if the temperature changes, we have to maintain the same temperature. So that's why we use platinum resistance heater for heating the thing. And the next one, it is the heat flux DSC. In heat flux DSC, the difference in heat flow into the sample difference is measured, but the sample temperature is changed at the constant, right? Sample and reference are connected by a low resistance heat flow path, a metal disc. The assembly is enclosed in a single furnace. So the commons required for the heat flux DSC are sample holder. It holds the sample and reference material, and we have a sensor. It is made up of chromal aluminum thermocouples furnace furnace. So this is the pictorial representation of the heat flux DSC. So here we have a furnace. So inside the furnace we have a sample and reference pan. And so as we heat, as the heating block heats, the two sample and the reference pan will be getting heated. So here we will be measuring the heat by using the thermoelectric disc thermocouple junction, and here we have a lid for placing the sample and the reference into the basket, and here we have a chromal disc and chromal wire for heat flux. So this is working. The main assembly of the cell is enclosed in a cylinder, silver heating black, which display heat to the specimen via a constant disc which is attached to the silver part. The disc has two raised platforms on which the sample and reference pans are placed. The chromal disc or connecting wires are attached to the underneath of each platform. The resulting chromal constant and thermocouples are used to determine the differential temperatures of inputs. So the DSC measures the glass transition state, melting and boiling points of the particular material, then crystallization time required for the material, percentage of crystallinity, then heats of fusion and reactions, specific heat capacity. So these are the things we can able to measure by using this differential scanning calorimetry. So the next one is the differential thermal analysis. Differential thermal analysis is a thermo-analytical technique which is used for thermal analysis where thermal changes can be studied. So from this we can able to know the thermal analysis as the thermal changes. So this is the pictorial representation of the DTA. So here we have a furnace. So sample and reference holders are placed inside the furnace. It is heated by the furnace, and the heat is maintained by the furnace temperature programmer, and we will be continuously monitoring the temperature by using the temperature sensor. And the heat, it is amplified, and it is sent to the computer through the amplifier readout device. The readout device is nothing but the computer. So here we have an insulator to maintain the distance between the furnace and the operating technician. So this is the general pictorial representation of DTA. So that's all about the other testing. Thank you.